Hello dear students, welcome to the second lecture of arithmetic progression. In this lecture, we will study about the formula to find out the nth term of an arithmetic progression represented by an, and the formula is an equal to a plus n minus 1d. An is the nth term, a is the first term of arithmetic progression, d is the common difference, and n is the number of the term of arithmetic progression. Let's see how can we use this formula. For example, if an arithmetic progression is given here and we have to find out the eighth term of given AP. So here arithmetic progression given 2, 5, 8, 11 like this, and we have to find out eighth term of this arithmetic progression. So in this arithmetic progression, you can see here first term, that is a, is given 2, and the common difference, it is represented by d. So the formula for common difference is a2 minus a1. So a2 is the second term, that is given 5, minus a1, that is the first term, that is 2. So the common difference is 3. Now here we want to find out eighth term of arithmetic progression. It means n is given 8. So if you use the formula is an equal to a plus n minus 1d. So here in place of n we will put 8, so it become a8 will be equal to a plus n minus 1, that is 8 minus 1d, or we can directly write a8 equal to a plus 7d. You can use this formula directly. Suppose in place of a8, if you want to find out the 10th term of arithmetic progression, then we can write directly a plus 9d. If you want to find out the 20th term of arithmetic progression, then we can write directly formula a plus 19d. Here we will multiply n minus 1 with d. Here we have 10, so we will multiply 10 minus 1, that is 9d. Here if you want to find out 20th term, then 20 minus 1, that is 19 multiply with d. So this way you can directly use the formula. So here we want to find out the 8th term of AP. So we can write a8 equal to a plus 7d. So here a is 2, that is given 7, and d that we have calculated 3. So we get 8th term of arithmetic progression, that is 2 plus 21, that is equal to 23. So 8th term of this arithmetic progression is 23. This is our answer. If you want to check it, so you can see this series here. First term is 2, second is 5, third 8, then 11. So next term will be 14, then 17, then 20, and then 23. So you can see this is 1, 2, 3, 4, 5, 6, 7, and this is the 8th term of AP, that is 23. This is what you get here. 8th term of AP is 23. So this way, whenever you want to find any number of term of arithmetic progression, then you can use this formula here. An equal to a plus n minus 1d. Now see the different variety of questions asked based on this formula. Let's see the another question. This is the first type of question, similar to the example we have done right now. Find the 20th term of the sequence 7, 3, minus 1, minus 5, and so on. So here we want to find a 20th term. So we will take n equal to 20. And from this arithmetic progression, you can see first term a, that is equal to 7. Then common difference, the formula is a2 minus a1. So you can see a2, that is second term of this arithmetic progression, is 3. minus a1, that is the first term, is 7. So we get the common difference minus 4. Now we can use the formula here. Formula is an equal to a plus n minus 1 d. Yeah, we have to find 20th term, so we will put a20 equal to a plus 20 minus 1 d, that is equal to a plus 19d. So here a is 7 plus 19 multiply with d, so d is minus 4. So if you simplify this, 7 plus 19 multiply with minus 4, that will be minus 76. So we get 20th term of AP is equal to 7 plus minus 76. So 7 minus 76, that is equal to minus 69. Minus 69 is the 20th term of given arithmetic progression. This is the first type of question. Now see the another type of question. Question number 2. How many terms are there in the sequence of 3, 6, 9, 12, up to 111? So in this question, what we have to find here? How many terms are there? How many terms are there? It means we have to find out number of terms. Value of n we have to find out. The first term of arithmetic progression is given, that is a equal to 3. The common difference we can find out by the formula a2 minus a1. a2 is the second term, that is 6, and a1, that is first term, 3. So we get the common difference 3. And total number of term we have to find out. The last term is 111. It means here an is given to us. An is 111. So now if you use the formula, an equal to a plus n minus 1 multiplied with d. So here an is 111 given. A is 3. We have to find the value of n. So n minus 1, keep it as it is, and d is 3. Now here this 3 will go into the left hand side. So this become 111 minus 3 is equal to n minus 1 multiplied with 3. So here 111 minus 3, that become 108 is equal to n minus 1 multiplied with 3. Now this 3 is in multiplication here, so it will go into the denominator this side. So we get n minus 1 equal to 108 divided by 3, that will be equal to 36. So we get n minus 1 equal to 36. So we get n equal to 36 plus 1. So we get n equal to 37. It means in this arithmetic progression, in this series, the 37th term of this arithmetic progression will be 111. Let's see the next question. Which term of the arithmetic progression 21, 18, 15, is minus 81? So this question is also similar to the question number 2. Here also, which term means we have to find out the number of term. First term of this arithmetic progression, that is a is given 21. Common difference, that is equal to a2 minus a1. So a2 is 18 and a1 is 21. So the common difference we get minus 3. And 81 minus 81, that is the nth number of term, that is equal to minus 81. So if you use the formula here, an equal to a plus n minus 1 multiply with b. So here an is minus 81, a is given 21 plus n minus 1 and d is minus 3. So here this 21 will go into the left hand side, so this become minus 81 minus 21 is equal to n minus 1 multiply with minus 3. So minus 81 minus 21 to become minus 102 is equal to n minus 1 multiply with minus 3. Now this minus 3 will go into the denominator here. So we get n minus 1 equal to minus 102 divided by minus 3. Here minus minus cancel out and 102 divided by 3. So you will get 34. So here we get n minus 1 equal to 34. So n equal to 34 plus 1, that is 35. So here we can say that 35th term of this given AP will be minus 81. See the question number 4. Determine the 25th term of an AP whose 7th term is given minus 1 and 16th term is given 17. So we can write down the given data. A7 is given minus 1 and 16th term, that is A16 is given 17, and we have to find out 25th term. So A25, that we need to find out here. So first of all, A7 is given minus 1. So we know the formula of A7. You can write formula for A7, A plus 6D, that is equal to minus 1. And same way we know the formula for A16, that is A plus 15D, that is given 17. Now if you want to calculate the value of A and D from those two equations, first of all subtract those two equations. So if you do the subtraction of those two equations, here A minus A will be cancelled out, then 6D minus 15D, that will be minus 9D, is equal to your minus 1 minus 17, that will be minus 18. So you will get D equal to minus 18 divided by minus 9. So we get D equal to 2. Now we can put value of D in any of this equation, either in this equation or in this equation. For example, if you put D equal to 2 in this equation, let's say this is equation 1. So if you put D equal to 2 in equation 1, so here you can write equation 1 is A plus 6D, that is equal to minus 1. So A plus 6 in place of D we will put 2. So we get A plus 12 equal to minus 1. You can say A equal to minus 1 minus 12. So we get A equal to minus 13. So here we get the value of A and value of D. D equal to 2 and A equal to minus 13. Now here we want to determine A25. So to find out the A25, we know the formula for A25, that is A plus 24D. A is given here minus 13 plus 24 and D is 2. So we get the value of A25 minus 13 plus this is 48. So we get A25 is equal to 35. This is our answer. The 25th term of given arithmetic progression will be 35. Let's see the next problem. How many 2-digit numbers are divisible by 8? How many 2-digit numbers are divisible by 8? So, how many means we have to find out n number of terms that we need to find out. And the number of terms which are divisible by 8, 2-digit number divisible by 8. So, first 2-digit number that will be divisible by 8 will be 16. Second number will be 24. Third number will be 32, like this. And the last 2-digit number that will be divisible by 8 will be 96. So here we have to find out the total number of terms. So this is our required AP. Now you can see the first term of AP is 16. Common difference of this arithmetic progression is 8. The last term, the nth term of AP is 96, and we have to find out the value of n. So we can use the formula an equal to a plus n minus 1 d. An is 96, a is 16 plus n, we have to find out n minus 1, and d is 8. So if you take this 16 to left hand side, then it becomes 96 minus 16 is equal to n minus 1 multiply with 8. So that will be 80 is equal to n minus 1 multiply with 8. So here we get n minus 1 will be equal to 80 divided by 8. So we get n minus 1 equal to 10, and hence n equal to 10 plus 1, that is 11. So here we can say there will be total 11 numbers, 11 2-digit numbers that will be divisible by 8. Let's see the question number 6. A sum of 2000 rupees is invested at 7% simple interest per year. Calculate the interest at the end of each year. Do those interest form an AP? This is the question number 1. If so, and find the interest at the end of 20th year making use of this fact. So first of all, to calculate this question, we should know the formula of simple interest. The formula of simple interest is PRT divided by 100. The P is the principal amount, the amount invested, that is 2000 given here, and R is the rate of interest, so your rate of interest is 7%, and T is the time period. For example, if you want to calculate the interest for first year, then we will put T equal to 1. If you want to calculate the interest for 2 years, then we will put T equal to 2, like this. So let's find out simple interest at the end of first year. So here we know the formula PRT divided by 100. P is 2000, R is 7, and T for first year we will take T equal to 1 divided by 100. So 0, 0 cancel out. So here we get the interest at the end of first year will be 7 multiplied by 20, that is 140 rupees. Now same way, if you want to calculate the interest at the end of second year, and you can say simple interest for the end of second year will be PART divided by 100. Here we will take principal amount same 2000, rate of interest is 7, and time period here we will take 2 year. So for the 2 year, this will be equal to 0, 0 will be cancel out. So 7 multiplied by 20 multiplied by 2, so we'll get 280 rupees. So simple interest at the end of second year is 280. Same way, to calculate the simple interest at the end of third year, so use the same formula, PRT divided by 100, principal amount is 2000, rate of interest is 7%, and time period here we will take 3, will divide by 100. So here 0, 0 cancel out. So here we get 7 multiplied by 20 multiplied by 3, so we'll get 420 rupees. So if you observe here, we get the interest at the end of first year is 140, interest at the end of second year is 280, and interest at the end of third year is 420. So you can write here interest at the end of first year is 140, second year we get 280, third year we get 420, and so on. So here you can see the difference between consecutive number is same. If you want to find out the common difference, you can use the formula A2 minus A1. Here the second term is 280 and the first term is 140. So we get the common difference, 280 minus 140 is equal to 140. Same way, if you use the formula A3 minus A2, A3 is 420 and A2 is 280. Then also we get the same result. So here we get common difference is remain same. So we can say that interest per year will make an arithmetic progression. So we get the answer of first question. First question was, do those interest form an AP? So answer is yes, they will form an arithmetic progression. Now second question is, if so, then find out the interest at the end of 20th year. So we have to find out the interest at the end of 20 year. So for 20 year, we will put n equal to 20. Here in this arithmetic progression, the first term is 140 and common difference is also 140. So if you put the formula an equal to a plus n minus 1b, here an, that is we have to find out a20, a is 140 plus n minus 1, so n is 20 minus 1 and d is also 140. So that will be 140 plus 19 multiplied with 140. So you get the interest at the end of 20 year will be 2800. This is the answer of our question. Let's see the next question. See the next type of question. determine the 10th term from the end of the AP. From the end of the AP. Here the AP is given 4, 9, 14 up to 254. And we have to find out the 10th term from end. Means we have to find out 10th term from this 254. So to find out the 10th term from the end of the AP, first of all, we will write this AP in the reverse way. We can write this AP like this. First term will be 254. Then next term will be, there you can see the difference between 4 and 9 is 5. The difference between 9 and 14 is also 5. So the difference between 254 and its previous term, that will also 5. So the next term will be 249, right? Like this. And the second last term will be 9 and last term of AP will be 4. So we have written this AP in reverse way. 2, 9, 14 up to 254, that was the given, so we write in reverse way. Now, if you see the question, we have to find out the 10th term from the end of this AP. So here in this AP, we have to find 10th term from starting of this AP. Right? From 254, we have to find out 10th term. So we will take n equal to 10. First term will be 254 and the common difference a2 minus a1. So a2 is 249 minus a1 is 254. So the common difference will be minus 5. Now put this in the formula. An equal to a plus n minus 1 d. We have to find out 10th term. A10 will be equal to a, that will be 254 plus n minus 1, that is 10 minus 1 multiply d. D is minus 5. So we'll get the answer 254 plus 10 minus 1, that is 9, multiply with minus 5. So that will be 254 minus 9 5 is 45. So that the 10th term of the term AP is 209. So this was the special type of question in which we have to find the 10th term from the end of the AP. So whenever you get this type of question, first of all we will write this given AP in the reverse way, and then we will find out the whatever number of terms we want to find out. Okay. So here in this question, the 10th term from the end of this AP will be 209. See the question number 8 here. Check whether 0 is the term of this arithmetic progression or not. So here the arithmetic progression is given 31, 28, 25 like this. We have to check whether 0 will be any term of this arithmetic progression or not. So first of all, if you observe this arithmetic progression, you can see here the first term of AP is 31. Then common difference, that is a2 minus a1. a2 is 28 minus a1 is 31. So we get the common difference d equal to minus 3. Now we have to check whether 0 is the term of this arithmetic progression or not. So let's take an equal to 0 and find out the value of n. So if you put the formula, here we got an equal to a plus n minus 1d. An is 0, a is 31 plus n minus 1 and d is minus 3. So if you simplify this 31 will go into the left hand side, from minus 31 equal to n minus 1 multiplied with minus 3. This minus 3 will go into the division, so we will get n minus 1 equal to minus 31 divided by minus 3. Minus minus will be cancelled out. So we get n minus 1 equal to 31 divided by 3, that is 10.33. You can say n equal to 10.33 plus 1. So we will get n equal to 11.33. So now you can see your n is the number of term and the number of term is 11.33, which is not possible because the number of term, either it may be 11 or it may be 12 or 13. It should be any whole number. Here we get n equal to 11.33. So number of term should not be in decimal point. It means we can say that 0 will not be the term of this arithmetic progression. 0 will lie between the 11th term and 12th term. 0 will lie in between its 11th and 12th term of this arithmetic progression. So answer is 0 will not be the term of this arithmetic progression. Let's see the question number 9. In a flower bed, there are 43 rose plants in a first row. 43 rose plants in first row, 41 in second row, 39 in third row, and so on. There are 11 rose plants in the last row. So how many rows are there in the flower bed? So if you see the question, there are 43 rose plants in the first row. So the first term is 43, 41 in the second row, 39 in the third row, and so on, and the 11 rose plants in the last row. So here first term of the arithmetic progression, that is 43. Then if you want to find out the common difference, formula is a2 minus a1. So a2 means second term, that is 41, and the first term is 43. So common difference is minus 2. Now here we want to find how many number of row. So we have to find out the value of n, and the nth term, that is last term, an is given 11. So just put the formula of an equal to a plus n minus 1 multiplied d. An is 11, a is 43. You have to find the value of n minus 1 as it is, and d is minus 2. If you take this 43 to left hand side, then we get 11 minus 43 is equal to n minus 1 multiplied with minus 2. So 11 minus 43, that is minus 32, is equal to n minus 1 multiplied with minus 2. So here we get n minus 1 equal to minus 32 divided by minus 2. So minus minus cancel out. So we get 16. N minus 1 equal to 16. So we will get n equal to 16 plus 1, that will be 17. So this is our answer. There will be total 17 rows will be there. Okay. Let's move to the next question. Question number 10. How many numbers lie between 10 and 300? Between 10 and 300, which divides by 4 and leave a remainder 3. See the question again. How many numbers lie between 10 and 300, which divides by 4 and leave a remainder 3? So if you think about the first number, that is between 10 and 300, divide by 4 and leaves the remainder 3. So the first number will be 15. If you divide 15 by 4, then it will leave the remainder 3. So this is the first number, that is between 10 and 300. When divided by 4, leaves the remainder 3. The second number will be 19. 19 is the second number. If you divide 19 by 4, then it will leave the remainder 3. Same way, the third number will be 23, and like this. And think about the last number, that will be divided by 4 and leave the remainder 3. So if you see, the last number will be 299. If you divide 299 by 4, then you will get the remainder 3. So here we got the arithmetic progression 15, 19, 23 up to 299. And you have to find how many numbers are lie between 10 and 300. How many means we have to find total number n, we have to find out. First term of AP, that is A, is given 15. The common difference is A2 minus A1. So A2 is 19 and A1 is 15. So we get the common difference equal to 4. A is 15. And here last number, that is AN. AN is given 299. So if you use the formula here, AN equal to A plus N minus 1D. So AN is 299 equal to A is 15 plus N minus 1 and D is 4. So if you solve this 15 will go into the left hand side. So we get 299 minus 15 equal to N minus 1 multiply with 4. So if you solve for the value of N, we get N minus 1 multiply with 4 will be equal to 299 minus 15. So we will get 284. So we get N minus 1 equal to 284 divided by 4. So we will get N minus 1 equal to, this will be 284 divided by 4. So we will get 71. So here N will be equal to, this minus 1 become plus 1. So 71 plus 1. So we get N equal to 72. So answer is N equal to 72. There will be total 72 numbers lie between 10 and 300, which when divided by 4 leaves the remainder 3. Let's move to the next question. Question number 11. Which term of AP, the AP is given 121, 117, 113 and so on. So which term of this AP will be its first negative term? So which term means we have to find N. Which term of this AP will be the first negative term? So if you think about first negative term in this AP, then first negative term will be come after 0. So let's find out the at which number of this term we will get the 0. So let's take AN equal to 0. The first term of this series A, that is equal to 121, and common difference if you find out A2 minus A1, A2 is 170 and A1 is 121. So we get the common difference 4 minus 4. Okay. So let's find out the place of 0. At which number we get 0. So let's put the formula AN equal to A plus N minus 1D. Here in place of AN we will put 0. A is 121 plus n minus 1 and D is minus 4. So if you simplify this 121 come to this side, become minus 121 equal to n minus 1 multiply with minus 4. So we get n minus 1 equal to minus 121 divided by minus 4. So minus minus cancel out. So we get n minus 1 equal to 121 divided by 4. So we will get 30.25. So hence we get n equal to 30.25 plus 1. So we get n equal to 31.25. So we get n equal to 31.25. It means what? It means the 0 will be lie between 31st term and 32nd term. And if you observe this series, here we can say that 31st term will be positive term and 32nd term is come after 0. So 32nd term will be its first negative term. So our answer is n equal to 32 will be the first negative term of this arithmetic progression. See the beauty of this question. Let's see the next question. Question number 12. If 10 times a 10th term of an AP is 15 times 15th term, so that 25th term of AP is 0. Read it again. 10 times 10th term of an AP is equal to 15 times 15th term. So you can write here 10 times 10th term. So you can write 10 times a 10 is equal to 15 times 15 terms. So 15 times a 15. This is given and we have to prove that 25th term of an AP is 0. So here we have to prove A25 is equal to 0. That we need to prove. So first of all solve this 10 times 10th term. So A10, so we can write A10 will be A plus 9D is equal to 15. A15, so you can write A15 is A plus 14D. So if you simplify this, multiply this 10 into the brackets, so you will get 10A plus 10 multiplied with 9 will be 90D. This side, this 15 multiplied with A is 15A plus 15 multiplied with 14. So we get 210D. Now if you take this 10A and 90D to right hand side, then we get 15A minus 10A plus 210D minus 90D is equal to 0. Or if you further simplify it, we will get 15A minus 10A, that become 5A plus 210D minus 90D, so we will get 120D is equal to 0. Or we can say 5A equal to minus 120D, or if you divide this 5 here, then we get A equal to minus 120D divided by 5. So that will be equal to, if you cancel out this, we will get 2, 4. So we will get A equal to minus 24D. So here we get one result, A equal to minus 24D. Now here we want to prove that A25 equal to 0. So if you put the formula of A25, A25 equal to A plus 24D, and see here, let's see, this is equation 1. So from equation 1, in place of A we can write minus 24D. So in place of A put minus 24D plus 24D. So here we get minus 24 plus 24, I will cancel out. So answer is 0. So we get 25th term of an AP is 0. This is what we need to prove here. Hence proved. So these are the different types of question asked based on the only one formula. The formula is nth term of AP, an equal to a plus n minus 1d. And now based on this formula, based on these questions, you can solve those questions on your own. So these are the practice problems for you. So here we end our lecture.